Hydrology and Water Resource Engineering. Next topic in Unit 5 is properties of aquifers. An aquifer is a wet underground layer of water bearing permeable rock or unconsolidated material from which groundwater can be usefully extracted using a water well. This is a diagram which represent at below the water table level there will be aquitard, and after that artesian aquifer, and last is the lower aquitard. Next, confining layer is geological unit with little or no intrinsic permeability. Next, aquifer is absolutely impermeable unit that will not transfer water. Next one, aquitard, a layer with low permeability that can store groundwater and transmit it slowly from one aquifer to another. Unconfined and confined aquifer, and aquifer without or with confining layer on the top. Next one, leaky aquifer is a confined aquifer with an aquitard as one of its boundaries. Next one, perched aquifer, a layer of saturated water that forms due to accumulation above the impermeable lens. Example, clay. Last one, water table, depth where the soil becomes completely saturated. Next, aquifer are essentially porous media, and so the properties led to the properties of porous media as porosity, grain size distribution, specific yield, hydraulic conductivity and permeability, and compressibility. At first, porosity is the ratio of volume of voids to the total volume. That the formula N is equal to VV by VT. Although sometimes we express it as a percentage by multiplying by 100. Next one, what does porosity depends on? It depends on the packing and cubic packing material. Next, heterogeneous particle size and shape of the grains makes the difference. The first one is a greater porosity which has more pore space, so the water will easily gets filled, and in other side the less porosity, which means the water level which accumulated by this particle will be less. Next one, classification of sediment. As we know, these are all the sediments which is depends upon the engineering grain size classifications. Next, these are the typical porosity ranges for different types of soils, that is gravel, sand, silt, clay, rocks, etc. This is the grain size distribution. Very few materials has a uniform grain size. In order to measure the distribution of grain, successively sieve material through sieves of different size and built grain size distribution. Matrix D10 and D60. That is C is equal to D60 by D10, coefficient of uniformity. This is what the formula for coefficient of permeability. Next one, specific yield. A specific yield is a ratio of volume of water that drains from the saturated rocks and owing to the attraction of gravity to the total volume of saturated aquifer. Next one, specific retention is a rest of water that is retained. That formula is N is equal to SY divided by SR. This is what specific yield for different types of soil: clay, sandy clay, silt, fine sand, medium sand, coarse sand, gravelly sand, fine gravel, medium gravel, coarse gravel, limestone, etc. Next one, hydraulic conductivity. It was discovered by Henry Darcy, the father of groundwater hydrology. The measure of flow rate Q is to estimate specific discharge. The distance velocity. Q is the discharge by area. Next one, Darcy's has been Q is equal to minus K into dH by dx. Head drops with distance, which means dH by dx is negative, but Q should be positive. In a bed of packed bricks of flow rate is proportional to the diameter squared, and the flow rate is proportional to the specific weight of the fluid. That is Q directly proportional to rho g. The flow rate is inversely proportional to viscosity of the fluid. That means Q directly proportional to 1 by mu. Therefore, Q is equal to minus CD square y divided by mu into dH by dl. The porosity of the porous medium are only called intrinsic permeability. That means minus CD square is the intrinsic permeability. Next one, the y by mu is the property of the fluid only, where K 1 Darcy is equal to 1 into 10 minus 8 centimeter square, where K is equal to CD square. This is what hydraulic conductivity for different types of soil. Next one, Hazen formula for hydraulic conductivity. Recall from our classification of soil. Effective diameter D10. Hazen proposed the hydraulic conductivity given K is equal to C D10 by the whole square. C shape factor. How will we measure permeability? This is Q is equal to K into del H by L. Measure volume V over a time T. Hydraulic conductivity is given by K is equal to Q L divided by del H equal to V by AT into L divided by H. Therefore, K is equal to VL divided by ATH. Next one, transmissivity. We like to think about the groundwater in 2 dimension like a map. Therefore, we like to define the permeability over the depth of an aquifer. Transmissibility T is equal to Bk. These are all the properties of aquifer and types of aquifer. Thank you.